Hello everyone, we are now starting lesson number 3 of module 10 in which we see how we can build smart contracts in a more advanced context. In this lesson we will first of all go back to the notion of gas, which is a notion that should not be neglected when deploying smart contracts that are going to be used intensively. Next, I will present a framework for contract development, and I will end this lesson by talking about a project that provides code for smart contracts that has been audited and in which we can rely on. The objectives of this lesson are first of all to better understanding the concept of gas and what does it involve in the execution of a smart contract. The second point is the improvement of the environment of development, especially in the context of a large project where several developers will interact. And finally, the last point is to improve the confidence that we will put in the smart contracts we want to deploy. So, as we have seen in the previous courses, notably module 10.2 and 10.1, we can very quickly deploy a smart contract with the Remix tool. Nevertheless, in a large project, it's important to understand how you can optimize the production and efficiency of these smart contracts. So for this, we'll go back onto the notion of gas. What does this mean exactly? We are going to introduce a development environment called Truffle. And finally, I will talk about the OpenZeppelin library, which offers smart contract source code on which we can rely because they have been audited. So let's go back to this notion of gas. First of all, let's remember the units of measurement. Ether is the name of the cryptocurrency. ETH is just its stock symbol. A unit that is a little bit less known, nevertheless very important, is the Wei. The Wei is the smallest fraction of Ether we can handle. 1 Ether equals 10 power 18 Wei. Why is this unit? Simply because the EVM, the virtual machine, is not able to manipulate floating point numbers. And so, we are going to get by with this unit and usually a parameter that we call decimal, in particular in the contract ERC20. The notion of gas is the unit of measurement in terms of calculation quantity that will be used to define the cost of an operation. For example, an addition costs 3 gas. The price of gas defines the price that the user is willing to pay for a unit of gas. In general, we define its price in gigawei or Wei. And the notion of gas limit. This is the maximum amount of gas that the user is willing to pay for his transaction to succeed. Here is an extract of the different instructions that are supported by the Ethereum virtual machine. We can see, as I said in the previous example, that an addition costs 3 gas. A multiplication is a little more expensive. It costs 5 gas. But the instruction that will cost the most in the Ethereum blockchain is the S-store instruction that will cost 20,000 gas. Indeed, this instruction will modify the state of the blockchain. That's why it's so expensive. It will cost a little less if you reset an attribute of your smart contract or if you modify an attribute of the smart contract. In other words, if you change the state of the blockchain at a place where it had already been modified. About gas limit, this notion is important to understand. First of all, it allows to avoid spend a fortune. Indeed, imagine that your smart contract contains a logic error, for example, an infinite loop. Without this notion of gas limit, you could consume all your Ether. As you can see, the more you use expensive instructions or the more instructions are executed there, and the more it costs you to execute your smart contract. So it's important to have this notion of gas limit. It's a limit that you can set. There is a default value, but you can change it. However, if you set a gas limit too small, there is a risk that your smart contract may not be able to run completely. And then, well, you lose what you have consumed, and the transaction fails. The total cost of a transaction is equal to the gas price you set multiplied by the amount of gas used. In other words, The price of the gas multiplied by the number of instructions, but weighted by the cost of each instruction. So, a smart contract that will execute a lot of store, the famous instruction that modifies the state of the blockchain, is very expensive. The miners will give priority to the transaction with a high cost, of course. Therefore, if you are willing to pay a lot, you increase your chance that your transaction will be processed and thus enter in the next block of the blockchain. The price of the average gas is constantly changing. You can go to the ETH gas station website for more information and see what the average price of gas is currently set by users for the transaction to be included in the next block. I'm moving on to the next step of this lesson by introducing the Truffle framework. Truffle is a development environment that will be perfectly suited for large projects. It's not necessarily easy to handle, but when you are working with several developers, when you want to control everything, operation like the deployment or the test as well as seen, it's really going to be a perfect tool. Starting a project with Truffle is relatively simple. On your development machine, you need two tools, Node.js and npm. With npm, you will be able to install the framework. npm install Truffle. If you want to install it globally on your system, you should use the -g option. Finally, the Truffle command is available. Now you have an example. Truffle version should use a version of Truffle on all the tools associated with the Truffle, including a local blockchain, a compiler for the Solidity language, Node and Web3, the library that allows to interact, and Node is simply a tool for executing JavaScript. So for the example, we'll start with this simple smart contract again. I had called the storage in the previous lesson, which proposed an attribute, the number attribute, an unsigned integer on 256 bits, and two functions, a store function and a retrieve function. The store function allows you to modify the attributes, modify the value of our contract, and retrieve, which allows to retrieve this value. So, with the Truffle environment comes a local blockchain that runs locally on your machine, and with the Truffle develop command, we can access a console that allows you to interact with the framework. We can see that the command has started a blockchain with 10 accounts that are all credited and a private key for each of these accounts. Everything is done via line of code. Here we see an example of a line of code to deploy smart contracts. We take the example of our smart contracts of storage. Here are the 2 or 3 lines that are required to deploy the smart contract. These lines of code are in JavaScript file, which itself will be placed in the migration directory of our project. That you can specify in the Truffle configuration file on which blockchain you want to deploy your smart contract. Here you have an example of a blockchain that will be available locally. This is not a blockchain, but it's a node of the blockchain that will be locally deployed on your local machine. You can also, and this is a great strength of Truffle, test your smart contracts. You can write a set of tests of your smart contracts, and with the Truffle test command, you will be able to run all the tests you have written that will allow you to test your smart contract. So, in the example that is given, we are going to test the smart contract. To do this, we will first create an instance of it, we'll deploy it, we'll store the value 42 by calling the store function of our smart contract, we'll retrieve this value and check with an assert if we really get the value 42, and so with the command Truffle test, we see below that the test is passed. So now let's have a small demonstration of the Truffle framework. I run first a local blockchain. I'm using Ganache. Okay, available on this address. Then I create a new project. So I create a directory. I change for this directory. Now I will install Truffle. I use -g to install it globally. Okay, it fails because I forget to sudo the command. Truffle is now installed. I can check if it works with Truffle version. I obtain the version of each tools, and I can instantiate or create, a new project with Truffle in it. Some directory and files have been created for me. I can edit Truffle config.js to initialize the network I want to connect to. I will use the development networks. I uncomment int. Address of the host is correct, but the port number is not correct for Ganesh. It's 7545. Change 847. I will use a smart contract I already wrote before, so I put this very simple smart contract, my store smart contract, with a store function and a retrieve function and just one attribute, int256 called number. I can now try to compile this smart contract. Okay, it works. Here we have the ABI of our smart contracts. It's just a bit JSON file. Now I have to define a file to make it possible to deploy my smart contract automatically in my blockchain. For this, I create an instance of my smart contracts, and now I should be able to deploy it with the truffle migrate command. I fix my mistake by adding double quote, and it should work now. So we get the address of our smart contract. We can see in Ganesh in block 1 the transaction of my contracts which have been deployed in this local blockchain. Here we have the address of the contract. I launch now the Truffle console to interact with the framework. So I first create an instance of my smart contract deployed. Then I will get a reference to this instance. this instance has been initialized. I can use the store function of my smart contract to change the value for 10. Okay, A in exec signal is 10. That's good. I can try to retrieve it, and I obtain 10 in a big number format, but it is the right value. Now I can try to write some test function to make sure it works fine. If I change some parameters in my smart contracts. So I create an instance of my smart contract. I get some accounts and write my first test. Everything works asynchronously, so this is why we have async and wait instruction. I will use the first accounts. I deploy in my first test the contract. I call the function store. Next, I retrieve the attribute of my contract and do an assert. So the value written just before should be equal. And to test it, I just have to do truffle test. And it should pass. Okay. This does create a new transaction. 2A is 42 in hexadecimal. Because I declare my attribute public, I can call it directly without using the function retrieve. And obviously the test is still passing. Finally, I'd like to talk about this library, which is very useful, especially when you want to deploy smart contracts relatively standard. For example, an ERC20 or ERC721. There is library, a project called OpenZeppelin, which proposes a set of library of smart contracts. And the smart contracts have been audited, verified by a large community, and we are going to be able to use these code snippets to write our own smart contracts. I remind you that any programming error in a smart contract is catastrophic. So when we can rely on this type of smart contract, it's perfect. Here is an example of use. You just have to import the smart contract model you want to use. Obviously, this only works with smart contracts relatively standard. Then you just need your contract. We call it here simple collectibles. Inherits the smart contracts model that you want to rely on, typically a ERC721. And finally, in the constructor, you will be able to initialize the parameters of the smart contract used as a template. You can also override some function of the original smart contract when it is necessary. So let's start the second demonstration of this lesson. I already wrote a simple contract called Simple Collectible is based on one contract provided by OpenZepin, the ERC721 contract. So my contract inherits from ERC721 URL storage. Okay, I have a constructor which call the constructor of the mother class, and I overload just one function of this mother class, the function create collectible. Here I'll leave some comments because I already deployed the contracts, but I also deploy image and the JSON file. The JSON file used to describe the piece of art. This JSON file has been deployed on the IPFS file system. Okay, and you can see that in this JSON file there is also another URL also in IPFS, which is the picture itself, a simple draw of a little dog. Yes, if you click here you can see this piece of art. So I changed my MetaMask for Guerli because this smart contract has already been deployed on Guerli. Okay, here is the address of the smart contract, OX99. So I can connect Remix to this smart contract already deployed, change the environment for injected provider. Now I'm connected to Guerli. I put the address of the contract here, and I should have access to this contract directly. Okay, here it is, OX99. You can see a lot of functions already available. It comes from the mother class of my smart contract. So I mean ERC721 URL storage. If I click name, I get piece of art. If I click symbol, I get POE. Yes. And token counter, it means one. It means there is only one piece of art available in this NFT. So my address is OX52. If I put my address here, oh no, if I put the name, a number of the piece of art, there's only one, so the first one is 0, I get my address. And but my address says only one piece of art. And here I can get back the URL of the element 0 of this collectible. Now I can go to OpenSea, I mean to the testnet OpenSea with my address, and I should have access to all the NFT associated to my address on this contract. There is only one, but here it is available in the OpenCV interface. Here you have the number, the non-contract address. It works like a charm. So, in summary, in this lesson, we quickly return to the notion of gas, which is an important notion. It must not be neglected, especially when we deploy a contract that is going to be intensively used. We also briefly introduce the truffle development framework. You should know that there is an alternative called ADAT. These development environments are perfectly adapted to projects, let's say relatively large, where there will be several developers, several stakeholders. This will also allow to automate many tasks such as deployments, such as a testing process. Nevertheless, we will not neglect the Remix tool, which is really very well adapted for small projects. Finally, we have seen the library provided by the OpenZeppelin project that allows developers who wish to develop relatively standard smart contracts will be able to rely on this library to develop their own smart contracts where, in the end, they will only have to parameterize them and will have relatively confidence in the development of the smart contracts and the use that can be made of it. Thank you for your attention.